Hi children, come we will see the next topic in our 10th chapter, motion and measurements. Okay. Take your textbook, take page number 99. Standard units of measurements. Okay. In ancient times, the length of a foot, the width of a finger and the distance of a step were commonly used as different units of measurement. That we saw, no children, foot length, what, your hand span and all. Okay. The people of Indus Valley civilization must have used very good measurements of length, because we see evidence in excavations of perfectly geometrical constructions. We can see, okay, what evidence, we can get evidence from the excavations. Okay. A cubit as the length from the elbow to the finger tips was used in ancient Egypt and was also accepted as a unit of length in other parts of the world. People also use the foot as a unit of length in different parts of the world. These are all the different types of measurement, how they measure the measurement, how they did the measurement using different using the foot, using the hand span, okay, like that in different places of the world. Okay. So, people also use the foot as a unit of length in different parts of the world. The length of the foot used vary slightly from region to region. People measured a yard of cloth by the distance between the end of the outstretched arm and their chin. Okay. The Romans measured with their piece of with their pace or steps, with their steps. Okay. The Romans measured with their pace of by steps, how much steps. Okay. They measured the things. Okay. In India, small length measurements used were an angle or a angle, that is a finger length, or a mutti, okay, fist. Even today we can see flower sellers using their forearm as a unit of length for garlands, no children, that you may see, no. The flower sellers, see, that you may see in your market. If you go buy some garlands, they will measure the flower garlands by by angle or mutti, okay, by using their forearms as their measurement. Okay. Many such body parts continue to be in use as a unit of length when convenient. Even nowadays also many such body parts are continue to be in use. Okay. However, everyone's body parts could be of slightly different sizes. Okay. This must have caused confusion in measurement. Okay. In 1790, the French created a standard unit of measurement called the metric system. Okay. So, when in 1790 French, okay. So, what is this measurement? A standard measurement system, that is called metric system. Metric system. For the sake of uniformity, scientists all over the world have accepted a set of standard units of measurement. Okay. So, for the sake of uniformity, scientists all over the world accepted, okay, the standard units of measurement. The system of units now used is known as the International System of Units. That is system of units. Okay. International System of Units, that we call it as SI units. Okay. Understood, children? So, measurement that we are using is what is called International System of Units, that is the standard unit of measurement. Okay. Understood, children? SI unit. So, what is the SI unit to measure the length? Length is measured in what is the unit of length in SI unit is meter. Okay. Understood? And each meter is divided into 100 equal divisions called centimeter. Okay. Each centimeter has 10 equal division, which is called millimeter. Okay. So, 1 meter equal to 100 centimeter, 1 centimeter is equal to 10 millimeter. That you can see in your scale also. If you take your scale, see here, see if your scale, these are all centimeters. 0 to 1 is 1 centimeter, 1 to 2 is 2 centimeter, 2 to 3 is 3 centimeters. Like that 100 centimeters makes 1 meter. Okay, 100 centimeters make 1 meter, and this 0 to 1, no, there are 10 divisions are there. Those are all called millimeter. 10 millimeters makes 1 centimeter. Okay, look here, 10, see, 1, 2, 3, 4, this is 0, see, 1, 2, 3, 4, like that, no, 10 divisions. Okay, that is 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter. The 10 millimeters makes 1 centimeter. Okay, 10 millimeter means what? 1 centimeter, and like this, say 100 centimeters makes 1 meter. Understood, children? For measuring large distances, meter is not a convenient unit. Can we measure large distances using meter? No, children. So, we define a larger unit of length which is called kilometer. What? Kilometer. So, 1 kilometer is equal to 1000 meter. How much? 1000 meter. Now, we can repeat all our measurement activities using a standard scale and measured in SI units. Okay. So, we can measure the whatever the things we want using the SI units. Okay. It will be very easy. Then even what? It don't depend on, it won't change for person to person. Okay. It will be very equal for all the persons if we measure using these units. Okay. Correct measurement of length. Okay, correct measurement, how to measure length. Okay. In our daily life, we use various types of measuring devices. We use a metric scale. See, come to my next page, children. For measuring length. Okay, a tailor uses a tape, whereas a cloth merchant uses a meter rod. Okay. For measuring the length of an object, you must choose a suitable device. Okay, you cannot measure the girth of a tree or the size of your chest using a meter scale. For instance, measuring tape is more suitable for this. To what? You cannot able to measure the length of your chest using a scale. Okay, because it is not in a level. No, it is not in a straight line. So you can use what you can use. Yeah, measuring tape you can use in these places. Okay, to measure the girth of a tree or the size of your chest, you can use measuring tape to measure that. Okay. For small measurements such as the length of your pencil, you can use 15 centimeter scale from your geometry box. Okay, you may use a small scale to measure the length of the pencil. Okay, or you may use a long scale. Okay, understood, children? And if you take your small scale, how much was the length of your small scale? 15 centimeter. See here, how much? 15 centimeter, no, children? See here. So, to measure the smaller lengths, you can use your scale. Okay. So, in taking measurement of a length, we need to take care of the following. What we should take care? So, to measure the length, place the scale in contact with the object along its length. See, you should place the scale, okay, like this, okay, like at the edge the 0 point should come, 0 should come at the correct place, okay. Place the scale in contact with the object along its length. In some scales the ends may be broken, you may not be able to see the zero mark clearly. In such cases, you should avoid taking measurements from the 0 mark of the scale, okay. See, in some scales 0 mark won't be there. So, what you should do? You can start from 1 centimeter, and after the final measurement you can add 1 centimeter to that. Okay, understood, children? See, you can use any other full mark of the scale. Okay, full mark of the scale. Okay, see, say for 1 centimeter, then you must subtract the reading of this mark from the reading at the other end. Okay, you can subtract it. Okay. See here, if you are going to measure the length of the box, okay, by using a scale. Okay, so place the scale in contact with the edge. So if the 0 measurement is not there in the scale, you can start with 1, okay, and measure the length. After that, from that length, look here, from here 0 to how much? It is 13 centimeter, okay, 13.3 centimeter. but if you start from 1, it will be 14.3 centimeter. Now, you can subtract 1 centimeter from this 14.3 centimeter, you will get the exact measurement. Okay. Understood, children? Okay. See here. Here if you start from 0, the exact measurement is 13.3. Okay. And if there is no water, if it is a damaged scale, okay, and you can't able to see the 0 mark clearly, means you can start from 1 and get the measurement. Okay. That is nothing but 14.3. See here, since it is what? 1 is, you are not adding 0 to 1, no. So, that for what? You should subtract the length from it. Okay. So, 14.3 minus 1 will give you the exact measurement. Understood, children? Understood or not? Yeah. Okay. And correct position of the eye is also important for taking measurement. Okay. Your eye must be exactly in front of the point where the measurement is to be taken. Okay. Understood, children? So, you should correct position of the eye is also important. Okay. See, if you are seeing the measurement from the side, you can't able to see the exact measurement. Okay. So, you should what? Place what? Your eye must be exactly in front of that point. Your eye must be exactly in front of that point. Understood? So, in this way you can do one activity. You can measure the what? Height of the students in your class using a what? This type of scale. Okay. Understood, children? Measure that and you may enter that measurement. Who measure the height? Height in handspans. Use handspan as well as what? Use scale to measure the length. Okay. Do this activity. Okay, children? Come, we'll see the next topic. Okay. Measuring the length of a curved line. Okay. See, we cannot measure the length of a curved line directly by using a meter scale. We cannot, that we know, no, children. See, we cannot able to measure, okay, the length of a curved line using a what? Meter scale. We can use a thread to measure the length of a curved line. Instead, we can use what? Thread. Use a thread to measure the length of the curved line AB. Look here, this is a line AB, okay, curved line, okay. Put a knot on the thread near one of its ends. Place this knot on the point A, okay. Put a knot on one end using the thread, okay. Now, place a small portion of the thread along the line, keeping it taut using your fingers and thumb. Hold the thread at this end point with one hand. Using the other end, stretch a little more portion of the thread along the curved line. Look here, by now making a knot, putting a knot at the A point and stretching the what? Yeah, thread towards the curved line, okay, and putting one more knot at the end of the what? At the one end point, that is B point, and placing the thread along the line and keeping the one, putting one knot at the end. After that, taking out the what? Thread and measure, we can measure the length of the curved line. But you may observe that it will be very difficult to place the thread on the curved line, no, children. Is it easy to place the thread down? No, it will be very different. It may what? Go this side and that side like that. So, how to measure the length of the curved line? Come, we will see that. See, it is very different to measure the length of the curved line using the thread that we observe, no. So, we need some standard measurement to what? Measure these type of measurements. So, what we shall do? Come, we will see. See, think of some objects you have seen recently, okay. These may include a school bag, a mosquito, a table, people sitting on chairs or people moving about. The list may also have butterfly, a dog, a cow, your hands, a small baby, a piece of a stone, a horse, a ball, a bat, a moving train, a sewing machine, a wall clock or the hands of a clock. Okay. So, in this, which are all moving, which are all at rest? See, you might have noticed that the bird is not at the same place after some time, okay, while the table is at the same place. So, that you can decide whether which object is at rest or which object are in motion, okay. Come, we will see that. See, select a place where you find ants. Spread a large sheet of white paper on the ground and keep a little sugar on it. Ants are likely to be attracted to the sugar, no, and you will find many ants crawling on the sheet of paper soon. For any one ant, try and make a small mark with a pencil near its position. Okay. When it has just crawled onto the sheet of the paper, keep marking its position after a few seconds as it moves along on the sheet of paper. After some time, shake the paper free of the sugar and the ants. Connect the different points you have marked with the arrows to show the direction in which the ant was moving. Okay. See, like this, take one white sheet and put some sugar on it, okay, and observe the ants will come and eat it, no. So, observe a particular ant and make a mark of that ant on which way it is crawling, okay, understood. Okay children, see like this, after that take out the paper and remove the sugar. Now, each point you have marked shows where the ant moved to, okay, in intervals of a few seconds, okay. Motion seems to be some kind of change in the position of an object with time. So, what do you mean by motion? Motion is nothing but the change in its position, okay, of an object with time. Time to time it will change, okay. Change means, that is, it depends on the time, okay. Change in its position with time is called motion, okay. See, in the activity we saw like clock, sewing machine and an electric fan, it will not move from place to place, okay, understood. It will be at rest only, okay. But the ant, if you take, it will move from one place to another, okay. In intervals of few seconds, okay. Come children, come, we will see what are all the types of motion, okay, types of motion. You may have observed the motion of a vehicle on a straight road, march past of soldiers in a parade, okay, or the falling of a stone, okay. What kind of motion is this? Sprinters in a 100-meter race also move along a straight track, okay. So, see here, what kind of motion is this? That means what? A march past, look here children, march past of soldiers, okay, vehicle, which are all on a straight road, motion of a vehicle on a straight road, okay, and the sprinters in a 100-meter race, that means sprinters nothing but runners, okay, athlete, okay, athletes no, runners, okay, in a 100-meter race also move along a straight track. Can you think of more such examples for your surroundings? Yeah, you can observe that, yeah. See the movement of train, okay, the bird flying, aeroplane, the movement of aeroplane. See, if you observe all these things, you may find that the objects move along a straight line. The objects move along a straight line. This type of motion is called what? Rectilinear motion. What? Rectilinear motion. The motion that takes place in a straight line. Okay. What? Straight line is called rectilinear motion. Understood children? So, what is rectilinear motion? The motion occurs in a straight line is called rectilinear motion. Okay, this is one type of motions. Okay. Come, we will see one more type. Take a stone, tie a thread to it and whirl it with your hand. Okay, that you know, you may play at your home and all. Okay, observe that inside the home you should not play like that. Okay, the stone will fall on some objects and it will break that object. Okay, understood children? You should do it in outside your house only. So, observe the motion of the stone. We see that the stone moves along a circular path. Okay, in this motion, the distance of the stone from your hand remains the same. So, the distance between your hand and the stone remains the same. This type of motion is called circular motion. Okay, here the motion occurs in circular path. Look here, if you observe here, the fan, the movement, the motion of the fan is circular motion. Okay, understood? It rotates in circular motion. Okay, see here. Here also this are all what? Circular motions. Okay. See, you may see it in water park and all, giant wheel and all, amusement parks, you may see that. The motion of this giant wheel also circular motion. Here the motion happens in circular path. Okay. Okay, and the distance between the the distance between the center and the giant wheels are here the same. Okay. The motion of a point marked on the blade of an electric fan or the hands of a clock are examples of circular motion. Okay. What are the examples for circular motion? The motion of a point marked on the blade of an electric fan or the hands of a clock. Okay. And the hands of the clock or clocks also in circular motion only, no? Yes. The electric fan or the clock by themselves are not moving from one place to another, but the blades of the fan are moving. The fan is not entirely what? Moving. Here the only the blades are moving, and even in the clocks also the hands are moving. Okay. But the blades of the fan rotate, and so do the hands of the clock. Okay. If we mark a point anywhere on the blades of a fan or on the hands of a clock, the distance of this point from the center of the fan or the clock will remain the same as they rotate. Okay. The distance won't change, it will remain same. Okay. Only the rotation occurs here. Okay. In some cases, an object repeats its motion after some time. This type of motion is called periodic motion. In some cases, an object repeats its motion after some time. Okay, this type of motion is called periodic motion. Okay, that we will see in our next video, children.